Hello, welcome to Math 1324. This is Chapter 5, Section 2, Example 2. And in this example, we have that we want to find the future value of the ordinary annuity, and interest is compounded annually. R is $4,000, I is 0.09, and N is 10. And that's all we're told. Okay, and it doesn't seem like enough, but it is. And I will tell you, if I was not using MyLab Math for this, I wouldn't use these variables in this question, but we are using MyLab Math, so I have to let you know what's happening. First of all, compounded annually. That's important here because that means that little n is actually 1 for us. Now, why is that important? Because this n that they're talking about is that capital N I told you about earlier. Capital N is actually the little n times t that I like to use. So this little n being 10 here is actually this capital N. And little n is 1, so that means that t actually, so let's plug that in. So it means that 10 is equal to 1 times t. In other words, 10 equals t. So for us, t equals 10. Okay, so it's a little bit weird and convoluted here, but when we're compounding annually, n is actually the total time. Okay, so just be aware of that. The I here isn't actually the I that I would normally use, but it is the same in this case because R, remember, is the interest rate. So for this one, R would be 0.09, and the reason it would be 0.09 is because I is 0.09. But remember, I is just R over N, right? But what is this being little n? And little n is 1, so in this case, our I is R. It's a little bit weird, I know. That's the reason I'm doing this. Then, of course, our revenue stream, capital R, is 4,000. Good. And we want to find the future value of the ordinary annuity. Now, the future value, A, we don't know. That's what we want to figure out. To do so, we can use the formula, if you wish, which is this. And then just plug it in. So the future value is just going to be 4,000 times parentheses 1 plus R of 0.09 over 1 to the 1 times 10 minus 1 all over 0.09 over 1. And then you just type it in. I will show that in a second, but I want to go ahead and move on to another way of doing this. And the other way of doing this is actually the easiest way, and that's going to be the TVM solver. So for the TVM solver, remember what we have are n equals I% equals PV, PMT, FV, P/Y, C/Y, and for us, N should always be the last thing, unless it says unless it says an annuity due, which means you have to make the first payment immediately, then it should always be end. Okay. So capital N is, as I said up here, 10. I% is in fact the I here, but in percent format, which means we need to move that to the right too, making that 9%. The present value is going to be 0. And the reason that it must be 0 here is because we're assuming that there's nothing in the bank to begin with. If there was something in the bank to begin with, we would put some other value other than 0 there. As for PMT, that's how much we're making payments a month. So that's going to be our R. So in this case, because we're losing this money during that time, or excuse me, per year, my apologies. Because we're losing this money during that time, we can think of that as a negative here. So think of that as a negative 4,000. Future value, that's what we want to figure out. So that's going to be what our answer will be. Let's put a little square there because that's what you're going to see on the calculator whenever you figure it out. And then the P/Y, C/Y. For us, they'll always be the same. If you take a more advanced, I don't even know if it's an accounting class. If you take a more advanced finance class, P/Y, C/Y won't always be the same, but for us they will. So that means payments per year or compounding events per year. And in this case, we're compounding annually. So we're making one payment a year. There we go. And then we just type these in, which means, of course, that we need our calculator. So I'll see you there. Hello, welcome to Math 13. Welcome to the calculator. And in this, what I'm going to first do is I'm going to type in the formula. Now the formula was the following. We had 4,000 first, and then times some fraction. Now it's important to do the times first and then do a big fraction here. So if I do alpha y equals enter, notice that it creates the fraction like this. If you don't put the times there and you do alpha y equals enter, it'll make the 4,000 in the top. It's not a big problem if it's up there because you can just do big parentheses, but it's just easier not to. So 4,000 times, and then alpha y equals enter. So fraction over fraction. In the numerator, we had parentheses, 1 plus 0.09 over 1. Now, of course, you don't need to do over 1, but you can. So, and then 1 times, and then 10 for the amount of time. Then make sure you do that right arrow to get outside of the exponent, and then just minus 1. Then right arrow again, and into the denominator do 0.09 divided by 1. Click enter, and there you go. That is the future value of this ordinary annuity. Good. But we don't want to just rely on that. Let's go to our apps, finance, TVM solver. So in here, I want to go ahead and put all the numbers that we figured out. So capital N is 10. I% is 9. PV is 0 because there's nothing in there. PMT now is negative 4,000 because you're making these payments to somebody. We'll come back to the future value. Payments per year is 1, so that means compounding events per year is 1, and we're at end. So go back up here to future value and do alpha enter. And notice it does that little square next to it, and that's the exact same number that we got from the formula. So frankly, much easier and easier to see that we don't mess up. Okay, so the value that we got was 60,771.72. Now, again, I'm doing this to the cents because we're working with money. Sometimes the question is going to ask us to round to the nearest dollar, so make sure you do that. Just be sure to read the question. Alrighty, and that's pretty much it. I'm not going to go ahead and show you the actual, just writing down the number on the notes, which is what I just did. All I did is just wrote down the actual number there, $60,771.72. Alrighty, this is why we love the TVM solver. Alright, so I will go ahead and see you in the next video. Have fun.